Question number 10 is about transmitting electricity over long distances and also about the dangers of high voltages. The question starts with saying that you've been given a figure. It is called figure 13 and shows some overhead cables in the national grid. Remind yourself that there are three sections of the national grid. The first one is our step up transformer. Section number 3 is our step down transformer, and section 2 is transmission cables. Now the job of the step up transformer is to increase voltage and reduce current. The job of the step down transformer is to reduce voltage and increase current. We have to remember one thing, that we assume our transformers are 100% efficient. This means the amount of electrical energy that goes into the transformer is equal to the amount of energy that will come out of the transformer. There is an added advantage of using lower current because we know current produces heating effect in a cable. So if you use lower current, then less energy will be lost in the transmission cables, and therefore the efficiency of the system will increase. The question says explain the advantage of transmitting electricity at a very high potential difference. High potential difference means they're talking about this section. So we'll say high potential difference means lower current. So if the current is low, then we can say less energy is wasted as thermal energy in transmission cables. And as a result of this, what will happen? The efficiency is greater. Next part of the question says it is dangerous for a person to fly a kite near an overhead power cable. Figure 14 shows a person flying a kite. Now this is an important statement. So I can convert this statement into an understandable diagram. So I can say here, this is cable and here is my ground. Now if you recall, ground is always at 0 volt. This one will be at positive or negative. I can say this could be at positive or negative value. So I can say if it is positive, then the field lines will be downwards. Okay. If negative, I'm trying to say here, if the voltage of the cable is negative, ground is always at 0. In that case, your field lines will be going upward. This is my field lines. And I can say these are my field lines. Now you need to remind yourself, if this voltage here is very, very high, then this electric field will become very, very strong. And if it becomes very strong, then the air between these two sections will become conducting. In other words, I can say it will become ionized. Now here it says the person could receive a fatal electric shock if the kite was very close to, but not touching the power cable, was very close to. So we can say the number one thing that we have to say is, because we are looking at overhead power cables and we know that they carry very high voltages. I can say number one, the field strength is high. If the field strength is high, number two, I can then say air becomes ionized. This means it will become charged. If the air between these two sections becomes ionized and there is a string in between these two sections, then the string can conduct electricity. And as a result of this, what will happen? This person will get the shock. So we can then say string conducts charge to the person or we can say earth. Remember one thing here, the person is standing on the earth, so technically speaking this person is also at 0 volt. So this will get us 3 marks on this question. The question then further continues and it says a scientist investigated how the potential difference needed for air to conduct charge varies with the distance between a cable and earth. I can change this statement into a useful diagram here. I can say I've got a cable. Let's assume that it has a positive voltage, whereas the ground is always at 0 voltage. So I can say between cable and ground, there will be a potential difference. There's a distance between them two, and that is called D. So they're trying to investigate for a given distance T, what is the potential difference between the cable and the ground at which the air becomes ionized. Just to help you with this, I've written this statement. The results of the investigation are given to us in the form of a graph. We can see on this graph, as the distance between the cable and the earth increases, the potential difference required for the air to become ionized also increases. The question says the data in figure 15 gives the relationship between potential difference and the distance when the air is dry. It says when the humidity of air increases, the air becomes a better conductor of electricity. This means now low potential difference will be required, because it has now become a better conductor, so it will conduct at a lower potential difference. Draw a line on figure 15 to show how the potential difference changes with distance if the humidity of air increases. So all you have to do is you just have to use this understanding and plot another line on this graph. For 0.05, instead of this value, I'll need a lower voltage. So a line should be drawn which should be below the current line. So I've plotted another line which is below this line, indicating that this is for the humid air. This line is showing that for the same distance, you will now need a lower potential difference for the air to become ionized. Last part of question 10 says figure 16 shows a cross section through a power cable. So we've been given a cross section of a power cable, and we can see there are 2 types of cables used. There's a steel cable, and around this steel cable we've got aluminium cables. It says a 1 meter length of a single aluminium wire is a better conductor. Better conductor means it will have lower resistance than 1 meter of length, then a 1 meter length of the steel wire. So in other words, they're saying the steel wire has a lower conductivity. So this means it will have R will be higher. If R is higher, this means the current in this case will be lower here, and here the current will be higher. So this statement is important. Then it says the individual wires behave as if they are resistors connected in parallel. So when you connect resistors in parallel, you need to remember your total resistance will become low. And number 2 that you have to remember is that voltage, in other words PD, will be same for all resistors. It says explain why the current in the steel wire is different to the current in a single aluminium wire. They've used word different, so you will have to identify whether it is low or high. So I can say for the aluminium wire, R is low, therefore current will be high. For the steel wire, I can say R is high, therefore current will be lower. And then I need to link them together using this information. So there's an equation which is Ohm's law, which is V equals I times R. We've already identified that this is constant, okay, because we know that they are connected in parallel. So we'll say both have same P. So this will get you 2 marks. So 1 mark will be for stating the current in each wire, and the second one will be for stating the reasons.